One thing I will say here is that with regards to factoring, technically speaking, even though we're probably most familiar with using factoring to solve quadratic equations, you can use it for essentially any polynomial. Obviously, it's not always going to be as useful as it is with certain quadratics, but it is always an option where what you're doing is, well, breaking off terms and rewriting in terms of multiplication to more easily find a solution. Where, in particular, the book gives us a 5-step process for doing this, where what you might want to do is write the equation in that standard form, ax squared plus bx plus c equals 0, then completely factor the equation where possible, set each factor equal to 0, solve the equations for each factor that you got from step 3, and check the solutions. And I'm not going to keep the steps up here on the board for the example like I normally would, because a couple of them are kind of obvious. Really, the only important one is step 2, and that one's kind of a draw the rest of the owl thing. It's not a very useful guideline unless you really already are good at factoring. But hopefully by now you all have at least seen factoring, and even if you haven't, we're going to get a couple of examples here to build some more of that confidence. So for our first example, we want to solve the equation 3x squared minus 10x equals -8. And the first thing I want to do here is get it into that standard form so factoring looks more reasonable. And what we're going to do is we're going to take that 8 and just pull it over. So we'll have 3x squared minus 10x plus 8 is equal to 0. And then from there, it takes a little bit of thought. One thing we could do if you're comfortable with this is factor by grouping, where we could see that we could break off a 6x, stick it on there, and we'd have two 3x's. And then you'd be left with a 4x, and you'd have a 4x and an 8, so you'd have a 4, and that would actually work. But most people like the traditional way, so that's what I'm going to do instead. Where when you're trying to think about something in terms of that, what you need to remember is what multiplies to get these two and what's adding to get that one. Where thankfully, we'd like this more if it was a 1 because that'd make our lives a little easier for factoring, but 3 only factors into 3 and 1. It's prime. So if you need to factor, if you can factor, you're going to have a 3 and a 1 in there. Next, for that 8, well, you've got 1 and 8, or 2 and 4, where because this is positive, they have to have the same sign, and this one's also positive, so those have to have the same sign. Since this one's negative, it means we got a few negatives that we're going to be chasing around in here. And the way this is going to work out, in order to get 1 and 3, in this case 2 and 4, is we will have a dead marker for 1, 3x, and 1x to get the 3. This is equal to 0. And then for that 8, we're going to end up having a -2 and a -4. Again, it's a bit of a number puzzle here, figuring out for yourself, okay, I need 3, and I need 8, and I need 10. Just got to be a little bit subtle, a little bit careful, get a lot of those brain juices flowing towards your arithmetic again, but you should get to that point where by the zero product principle, this tells us that one of two things must be true. Either 3x minus 4 is equal to 0, or x minus 2 is equal to 0. And technically both can be true, but either or. Where solving these is pretty easy. For this one, you add over the 4, divide out the 3, and you would have x is equal to 4/3. While down here, you just add over the 2, and you would have x equals 2. And that would tell us that, at least propositionally, our solution set in this case is 4/3 and 2. And if you want to check that to be sure, you can. If you plug in 4/3 up there, it's not the very prettiest process to check, but you'd end up with 16 over 9 times 3 ends up being, oh boy, 16/3. and 10 times 4 over 3 is 40 thirds. So you'd have 16 minus 40 is 24 over 3, so that's 8 plus 8 is 0. Then for 2, you would have 2 times 4, or 2 times 2 is 4, times 3 is 12, minus 2 times 10 is 20, so negative 8 plus 8 is 0. So both of those solutions, thankfully, are good. But obviously we know factoring isn't the only way to go about this, so we're going to get one more next, where it's on a similar principle. Instead, we're going to be abusing a bit of notation with square roots.